Hey guys, welcome to my channel. Today we are going to discuss the two-sum problem by LeetCode. So it says that given an array of integers and an integer target, return indices of the two numbers such that they add up to the target. So there's an assumption given that there's exactly one solution for each list. So we don't need to worry about what in case there are multiple solutions, which solution do we need to return. So that's actually made simple for us already. And the other thing is that we need to return the indices of the two numbers and not the numbers themselves. So that's why if you look at these examples for this input 2, 7, 11, 15, the target is 9, and we need to return 0 and 1, which are the indices for 2 and 7 here. For this example, 3, 2, 4, and 6, 2 and 4 add up to these to the target, so we need to return 1 and 2. It's not, we cannot really return 0 and 0. It does add up, but I think we need to return two different indices. And the follow-up here is, can you come up with an algorithm that is less than O(n) square time complexity? So yes, let's actually discuss both, and the brute force, which is n square, and then we will discuss a an enhanced version which can actually solve this problem in linear time. So let's dive into the code. So I'll be using Python for for this problem. So let's actually start with the brute force uh, solution first. So brute force solution, it's actually it is the first thing that actually comes into mind when solving this problem. So you can actually go over the list twice in a nested fashion, and then for each given number and index, you can check if there is another number that that actually adds up to the target. So in case you find such number, you can just straightforward do a return there, and you don't need to then uh, yeah go through the rest of the rest of the iterations. So let's do that. uh, so for this, we can do for num in nums. Actually, we're going to need the index because we need to return the indices. So let's do index 1 num1, and we can use the enumerate method here, which actually iterates over in an indexed fashion. And then similar loop uh, enumerate nums. And what we can do here then is, I think we need to check for, if you look at this example 3, so we don't really need to return 0 and 0, or even example 2, we don't actually want to return 0 and 0. We need to return 1 and 2. So one thing is for sure, that we need the indices should not be the same. So if index 1 is not equal to index 2, only then we need to proceed with this. So we can check if basically if we can do it in the same. If index 1 is not equal to, and num1 plus num2 equals target, then just return the indices, which is index 1 and index 2. I mean, we don't need this return statement, but let's just put this here anyways, to to avoid any confusion that this is not returning anything. Uh, so let's try this out. Okay, cool. Yeah, it works. Let's submit this, and we can see that this is actually running and running, and you know it's not actually coming back quickly. So yeah, you can see that it took 8688 milliseconds, which is like only faster than like 5% of the Python 3 online submissions. So let's actually go back to the description, and we will try to enhance this to actually not be an n square, but like a linear, have the linear time complexity. So let's comment this out. So for our linear solution, we're going to use Python dictionary. So in Python dictionary, you can consider it as a key value store, and you are able to look up a key in constant time. So that is basically where all our gain will come from, and that's what will make our solution linear. So let's quote some solution. So let's say we have a scene dictionary which actually keeps track of whatever the numbers we have seen in the past, and this will actually help us look up the indices for any numbers that we have already iterated over, and we actually don't need to then loop through the array and look for that number in itself. So similar fashion, we're going to actually have a loop uh, using the enumerate method. So we'll need the index. We'll come to the check later on, like what we need to check and what we need to return. But after towards the end of each iteration, what we need is we need to build up some history. So we need to store the number and we need to store the index of that number against that. So now that we have, we're building up some history, what we'll need to check is if the difference of the current number from the target already exists in our history. So if target minus num is in the scene dictionary, then we just simply need to return the index. Actually, it will be a list of two numbers, so obviously the index would be the second one, and then we can just use target minus num here, so that should actually do very nicely. And similar to our previous example, we can just return an empty list in case the solution is not found. This is not going to be the case, but still, let's just put that there to avoid any confusion. So let's run this now. So yeah, works. If we submit it, wow, okay, we can see that it's already way faster than our previous solution. This was our uh, the the n squared solution, which actually took like almost 9 seconds to finish, as compared to this one, which is only 52 milliseconds. So that's quite a bit of gain, and it's already faster than 70% of the Python 3 online submissions, and the previous one was only, I think, beating 5%. So cool. Looks like we've got a decent solution now. We can actually have a debugger session. We can see how it actually iterates over the numbers, how it builds up the history. So if I click on debug, then you can see that on the first iteration, the scene history is empty. The current number is 2. So I mean, there's nothing in the scene. So this will return false. It will progress to this line number 9, where it will save in the history. Then it will move on to the next number, which is 7. The index is 1 in this case. Now we'll check if 9 minus 7, which is 2, is there in the history, which is there. So it is going to return the index of 2, which is 0, and obviously our current index where we are at in the iteration, which is 1. So that's it, guys, for this video and for this problem. Let me know in the comments if you like the video, if you would like me to discuss any other LeetCode problem. Also let me know in the comments, and please don't forget to subscribe to this channel. Thank you and bye.